Hello everyone, I am Naveen from Biomedical Engineering. Today I am taking the topic about is the transform analysis, recursive versus non-recursive system. What was the Z transform? And mathematical foundation, the Z transform is a powerful mathematical tool that converts discrete time signal into complex frequency domain representation. It serves as the discrete time counterpart to the Laplace transform for continuous systems, enabling analysis of system properties through algebraic manipulation rather than differential equation. Signal analysis converts time domain sequences into frequency domain representation. Stability testing determines system stability through pole location. System characterization describes system behavior through transfer function. Non-recursive system definition and characteristic. Non-recursive system, also known as finite impulse response system, produce output based solely or current and pass input values without feedback from previous outputs. These systems have a finite duration impulse response that naturally decays to zero. No feedback pathways, finite impulse response, linear phase capability, transfer form. Is a transform of non-recursive system. Moving average filter. Consider a point 3 point moving average. Y of n equal to 1 by 3 x of n plus x of n minus 1 plus x of n minus 2. Taking an Z transform, it converts into h of z equal to 1 by 3 1 plus z inverse plus z in minus 2. This system has two zeros and poles only at 0 z equal to 0. Transfer function analysis. FIR system equal to H is equal to sum of n by k equal to 0 bk z minus k. Identification system equation. Write the differential equation relating input and output. These are the given questions after the recursive system definition and characteristic. Input processing, feedback path, output generation. In the input processing, current input combined with weight and pass inputs, best outputs feedback and weighted in the calculation, final output determined by both input and the feedback. Feedback structures contains recursive loops where past output influences current output through feedback coefficient. Infinite impulse response theoretically continuous indefinitely through practically decays to negligible. Poles-based transfer function contains both poles and zeros determining frequency response and stability. Z transform of recursive system. First order blockage between recursive filter difference equations. First order system, y of n equal to x of n plus 0.5 y of n minus 1. Z transform yields h of z equal to 1 by 1 minus 0.5 z inverse. Second order system, h of z equal to 1 plus 2 z inverse by 1 minus 0.8 z inverse plus 0.2 z inverse. Poles and zeros, understanding system stability. Pole location, zero location, frequency response. Region of convergence, ROC. Infinite sequence, anti-casual sequences. ROC from angular region between radii R1 and R2 in the complex plane. ROC extends inward from innermost pole to region. Casual system, outward from outermost pole to infinity. Practical applications, key takeaways and future scope. Fundamental distinction, stability analysis, design choices. Thank you.